Hello there. Welcome to session 3 of Unit 3. In this session, we'll be talking about the atomic models. Let's look at the objectives. We have two objectives here, and the first objective is to discuss the evolution of the atomic model and describe J.J. Thomson, Ernest Rutherford, and Bohr's atomic model, and also understand the important features of the quantum mechanical model of an atom. Now, let's look at J.J. Thomson model of the atom. In our previous sections, I've already discussed, but here let's just take a brief description on the model that J.J. Thomson did for an atom. J.J. Thomson proposed in 1898 that the atom possesses a spherical shape that has a radius of approximately 10 raised to the power negative 10 meters, right? In which the positive charge is uniformly distributed. The electrons are embedded into it in such a way that it gives the most stable electrostatic arrangement. Many different names has been given to this model so far. Example is the watermelon, the rising pudding, or the plum pudding. Let's look at Rutherford's model of the atoms too. After a stream of high-energy alpha particles, which was bombarded onto a gold foil, and we have a photographic plate which is surrounding the gold foil. Rutherford was able to observe some 3 points here, and the first observation was almost all the alpha particles passed through the gold foil undeflected. And the second point was a small fraction of the alpha particles were deflected by small angles. A few alpha particles, that is approximately 1 in 20,000, bounced back. That is were deflected by nearly 180 degrees. So according to this, Rutherford proposed that 1. The positively charged and most of the mass of the atoms were condensely concentrated in the extremely small region. This is very small portion of the atom called the nucleus by Rutherford. So nucleus was generated by Rutherford. The nucleus is surrounded by electrons that moved around the nucleus at a very high speed in circular path that we call the orbit. Thus, Rutherford's model of the atom resembles the solar system, in which the nucleus plays the role of the sun and you have the electrons as the planets revolving around it. Lastly, the electrons and the nucleus are held up by electrostatic force of attraction. Now, which came about Bohr, and there are some 4 postulates that Bohr also did. And the first one was the electron occupies only certain orbits around the nucleus. Those orbits are stable and are called stationary orbits. Each orbit has an energy associated with it. The nearest orbit of the nucleus has an energy of E1, moving to the E2, E3, E4, E5, going upwards. Energy is absorbed when the electron jumps from a lower orbit, to a higher orbit, and energy is emitted when the electrons fall from a higher orbit to a lower orbit. So we have the nucleus here, and we have some shells around the nucleus, something like this. And we have as the nucleus, right? And we have an orbit here. And Bohr is saying anytime there's an electron, right, on either of the shells, and it rather moves from here to here, or moves from here to the higher one, or moves from the higher one to the lower one, or the lower one to the higher one, there's an emission or absorption of an electron, or let's say energy. The energy and the frequency of light emitted or absorbed can be calculated by using the difference between the two orbits' energy. So after the electrons has moved and there is an emission or absorption of energy, Bohr is saying we can calculate it using the two orbital energies.